All right, so today we're going to start talking about exponential functions. But I'm going to start off with a kind of silly question here. So would you rather have $1 million today, or would you rather have a penny today and the amount doubles each day for 30 days? So today you start with a penny, then tomorrow you have 2 pennies, and the next day you have 4 pennies. So each day it'll double. Or would you rather have $1 million? So think about it just for a second. Kind of make your decision. And then we're going to look at the actual numbers here. All right, so hopefully you've made a decision now. And on this one, so we have our silly little pieces here. But you can see on day 1, so remember you either took $1 million or the penny. So on day 1, you have 1 penny, and at the end of day 1, you'd have 2 pennies. It'll double. And then 4 pennies, 8 pennies, 16 pennies. So it's going pretty small. You don't have a lot of money here, but look at by day 15, you have $327.68. By day, let's see, is this 1, 2, 3? Here's $1 million. So because I can count over, you didn't put the decimals in or the commas in here, but by day 27, I have $1,342,177.28. So by day 27, I already have more than $1 million. I have $342,000 more than $1 million after 27 days. And by day 30, that's definitely a much bigger number because we can count over the decimals here. That's $10,737,418.24, which he's got here. So taking the $1 million, you have $1 million right this minute. But if you took the penny and it doubled every single day, for 30 days, you'd have $10 million, almost $11 million. So this is an idea of an exponential function. It grows very, very quickly. So at first, it might grow a little slower, but then all of a sudden it starts shooting up really, really quickly, right? We're going from pennies to thousands very, very quickly. Within 20 days here, we have $10,000, right? When we started with a penny. So this is just a kind of basic idea of an exponential function. So what we're going to do is we're going to take a look at how to graph an exponential function. So an exponential function in the form f of x, remember that's function notation, equals a times b to the x power. So if it's in this form, it will pass through 0a. Remember, this does not have a vertex like our parabolas did, where we have like a bottom and a top because it's a U shape. This is not going to be a U shape anymore. So we'll get to see that in just a moment. It does have a very different shape on it. So this is not a vertex, but it will pass through this point. It's a nice thing to know so I know kind of where to start, right? So whatever that a term is, that's going to be my y value for this point, and then 0 for x. So exponential function will either grow or decay. So it's either going up very quickly, like our money situation that we were just looking at, or it's going to decay very quickly. And then an example of that is radioactive material. Usually has a very short half-life. Well, not a very short half-life. Short in the terms of Earth, I think. Half-life. But every day, there's certain radioactive material where you could say, like, if it had a half-life of a day, every day if you were looking at that radioactive material, it would be gone. It'd be half gone. But if you think about that, it will never actually be gone. If it's only ever half gone, it's just getting smaller and smaller and smaller into eternity. It's never actually gone. It's just half of what it was the day before. Okay, so it's an interesting concept there, but it's never actually gone. It's just getting very small very quickly or getting large very quickly. This can be determined by the b term that's in this format in the standard equation. If b is greater than 1, then it's growth. If b is less than 1, then it's decay. So that just lets us know, is it going to be growing or decaying? So we're going to graph this exponential function here. So we have 3 halves. That's larger than 1, right? 3 divided by 2 is larger than 1. So this is actually going to be a growth function to the x power. So now we have to choose 5 points. I didn't put those directions on here, but Alex does require 5 points in order to graph this function for you. So I chose the 5 points, and if you notice the one in the middle, I did the same thing when we did vertex. So I did the 0a for this first one in the middle so that you can see how it's going to work out. And then I did 2 to the left and 2 to the right. So -2, if I plug in f of -2, I get 3 halves to the -2 power. remember the negative 2, a negative exponent kind of tells me it's in the wrong position. So I flip the fraction over, I have 2/3, and then it's positive 2. Okay, so it's just a very quick way to deal with that negative exponent. Remember, it does not mean a negative number. Okay, so now I have 2 squared and 3 squared, so I get 4 and 9 because it's 2 times 2 and 3 times 3. Okay, so my first coordinate here that I have is negative 2 and 4/9. I'm going to need to use the coordinate graphing tool on this one for sure because I can't graph 4/9. It's not going to let me do that. So my next number I chose was negative 1. So I have a negative exponent again. I'm going to flip this over. So I have 2/3 and then it becomes a positive 1 because I fixed the orientation. That negative just tells me it's in the wrong place. Flip them both over because I would have 3 to the negative 1 and 2 to the negative 1. Well, again, a negative exponent just tells me it's in the wrong place in the fraction. It's a kind of simple way of thinking of it. Okay, so 2/3 to the first power is just 2/3. All right, now I'm going to put 0 in. So 0, this one should be the number that's in front here, which is actually a 1. If I don't see a number in front, it's a 1. Okay, well, anything to the 0 power is, in fact, 1. So it doesn't matter if it's a million. It doesn't matter if it's a fraction like this one. If I have a 0 power, it's immediately 1. Okay. Now I'm going to put 1 in. So 3/2 to the first power, well, that's just 3/2. And then I'm going to put up my 2 in. So 3/2 to the second power, well, I'm going to square them both again. So 3 times 3 and 2 times 2, and I get 9/4. All right, so now I have my 5 coordinates. I need to graph them. So I'm going to go negative 2 and 4/9. Oh, you can kind of see I did that a little quickly. And then my negative 1 and 2/3, my 0 and my 1. Here's my 1 and 3/2, and here's my 2 and 9/4. And I'm just I'm estimating that as best I can on here. And then you can see I connect this line. Now you're going to have tools on Alex that are going to give you a much nicer line than this where you don't have this kind of wiggliness going on. But I'll show you what it looks like on the next one when we do this very next problem, what it looks like on Alex. So on this one, I'm going to choose my points again. So I have negative 2, negative 1, 0, 1, and 2. You really don't have to focus on that 1/2, the 0a term, unless you want to. It's not required. But with this one, if you choose 0 for x, you're automatically going to end up with that negative 1/2 because that's the a term. Remember from this page, when I said if it's an f of x equals a to the b times b to the x power, I'm going to have 0a. Well, that's all I'm showing you here. If I have 0, then whatever that a term is going to be my y-intercept. All right, so I'm going to plug in negative 2. So I have f of negative 2 equals negative 1/2 times 2 to the negative 2. I need to flip over the 2, so it becomes 1/2, and now it's a positive exponent. So now I can apply that. It's a negative 1/2 still. I'm just kind of carrying that one along. 1/2 squared, well, 1 times 1 is 1, 2 times 2 is 4. And now I can multiply these two fractions together. So I have negative 1 times 1, and that gives me negative 1, and then 2 times 4 gives me 8. All right, so now I'm going to apply negative 1. So again, I have to flip this 2 over. That negative 1/2 is just going to follow along for a moment. So I have 1/2 to the first power, because I corrected it now that I flipped this over. So now I can just multiply negative 1/2 and 1/2, because anything to the first power is itself. So negative 1 times 1 is negative 1, and then 2 times 2 is 4. You don't really have to do this middle one, but you can simply plug it in if you want to, but I know it's going to be the 1/2. Remember, anything to the 0 power is 1, so negative 1/2 times 1 is negative 1/2. Okay, so that's why it ends up being that way. All right, now I'm going to put 1 in. I don't have to flip this over because it's a positive 1. I only flipped these over for these two because they were negatives. So now I'm going to go ahead and multiply. Remember, there is a 1 under here. So I have negative 1 times 2 and 2 times the 1 that's under this standard 2. So it's negative 2 divided by 2, which is negative 1. All right, and then I have f of 2. So negative 1/2 and 2 squared. Again, I don't have to flip it over. It's a positive exponent, but I do have to apply the exponent. So I get a 4, because 2 times 2 is 4. Now I'm going to multiply. So I have negative 1 times 4. That's where the negative 4 came from. And then 2 times 1, because there's a 1 under every number, right? Just like on this last one. So it's negative 4 divided by 2, which is negative 2. So now you can see this is what it'll look like on Alex when you actually graph these. So you'll use the plot a point tool for these ones, for all these fractions. These last two you could actually graph with the pencil tool if you wanted to. And then you'll click graph the function. So these are just tools off to the right-hand side of your screen when you do this, and this is what it will look like. All right, so this is graphing exponential functions. I hope that helped, and I will see you on the next video.